We need to obtain the value of derivative of y with respect to x whenever x and y are given in its parametric form. That means x and y are both dependent upon the parameter theta. So let's begin. We will begin with whatever we are provided with. Here we are given the function x, which is a multiplied to theta minus sine theta. And we have y, which is given by a multiplied to 1 plus cosine theta. Now, we'll take the derivative on both sides with respect to theta. So we have derivative of x with respect to theta, that's given by a multiplied to the derivative of theta with respect to theta will be 1 minus derivative of sine function will be the cosine function. So we'll have cosine of theta. And we'll take derivative of y with respect to theta. So this will be equal to a multiplied to derivative of 1 will be 0 because 1 is a constant. This will be added to derivative of cosine of theta. And we know that derivative of the cosine function is negative sine theta. Now, to find out derivative of y with respect to x, all we have to do is take derivative of y with respect to theta and we will divide it with the derivative of x with respect to theta. So we have already obtained derivative of y with respect to theta is negative a sine theta. So this will be divided by a multiplied to 1 minus cosine theta. So here a and a gets cancelled out and this gives us negative sine theta divided by 1 minus cosine theta. Now we can further simplify this. What we'll do, we'll use the half angle formula, which states that if we have sine theta, this can be also expressed as the product of 2 times sine theta over 2 times cosine of theta over 2. And if we have 1 minus cosine of theta, so this will be equals to 2 times sine squared theta over 2. We will replace this value in our numerator and denominator, and this is going to give us negative 2 times sine of theta over 2 multiplied to cosine of theta over 2. All thing divided by 1 minus cosine theta, which is 2 times sine squared theta over 2. This will be equals to negative. Now here 2 and 2 gets cancelled, so we have 1 sine theta over 2 cancelling out from both the numerator and the denominator. That leaves us with cosine theta over 2 divided by sine theta over 2, and that ratio is simply cotangent of theta over 2. Hence we have obtained the derivative of y with respect to x, and we see that the value is also in terms of the parameter theta.